Good day, my good fans out there. I remain your chemistry lecturer on social media by name Dr. D.I. June. In my last lecture, we were treating calculations based on Dalton's law of partial pressures. And we solve a part of a question given. And because of time constraint, I decided to treat the second part now. Look at the board here. An enclosed vessel contains 2.8 grams of nitrogen and 14.2 grams of chlorine at atmospheric pressure and 0 degrees Celsius. What will be the partial pressure of nitrogen if the temperature is raised to 180 degrees Celsius? And they give us the molecular mass of one atom of nitrogen as 14 grams, chlorine as 35.5 grams. And the first part we solved was the final pressure, which is the total pressure of the gas. So in the first lecture, we used the general gas equation, where we solved the pressure of the gas mixture. And we got the answer as 1261. Now, the second part is that we should calculate the partial pressure of nitrogen gas. There are two gases involved, nitrogen and chlorine. They are mixed up in a container. So they are all exerting pressures. We do not know. So now we want to know what pressure of nitrogen is being exerted in that mixture. That is what I want to answer now. Now, if you start with me from the Dalton's law of partial pressure, we come to a formula like this. Now, Pn2 means the partial pressure of nitrogen will be equal to number of moles of nitrogen all over number of moles of nitrogen plus chlorine times total pressure. Now, total pressure, we have known it from the previous calculation, 1261 millimeter mercury pressure. Now, but there is something also you must know as a chemistry student. That's why I put it here. Note, number of moles of a substance is equal to reacting mass of the substance all over molar mass of the substance. This is something you must equally know. And that is why, because this N equal to 14, Cl equal to 35.5 is not for a play. It is for a reason. And therefore I'm making it known to you why these things are here. So you must calculate the number of moles of nitrogen and that of chlorine. And to do that is to get this formula. Reacting mass of the substance. This substance could be chlorine or nitrogen. Molar mass of the substance. Now look at it. Now let's calculate now. Therefore, number of moles of nitrogen will be equal to 2.8 all over 28. 2.8 is here. That is the reactant mass. Then 28 is the molar mass of nitrogen. Now, how do you get 28 here? One atom of nitrogen is weighing 14 grams, and we have N2. There are two atoms. So 2 times 14 gives you 28 grams. So if you divide 2.8 by 28, you have 0.1 mole. That is for nitrogen. You will do the same for chlorine. The number of moles of chlorine will be equal to what? 14.2 over 71. 14.2 is here on the board here. So this is the reactant mass of chlorine gas in the mixture. Now, 71 is the molecular mass. Now, one atom of chlorine, one atom, weighs 35.5 grams. And Cl2 means 2 chlorine atoms. So 2 times 35.5 will give you 71. And if you divide 14.2 by 71, you arrive at what? 0.2 moles. Now, having known these values, let's come down. We are looking for the partial pressure of nitrogen gas in the gas mixture. Now, therefore, the Pn2 equal to the number of moles of nitrogen